Oxidizing agents that are used in titration they include potassium permanganate or potassium dichromate 6, and I've written here in acidic medium, and I'm going to explain what that one means. Okay? Number 2, we have reducing agents. Include iron 2 salts. E.g. iron 2 sulfate, solution, iron 2 sulfate solution, we also have ammonium iron 2. Ammonium iron 2 sulfate solution, written like this. It is a hydrated salt, so it has 6 molecules of water crystallization. So, the choice of these two salts is that they provide iron 2 ions. They provide iron 2 ions, which are very good reducing agents. Okay? Yeah. Maybe you're asking yourself, why are we saying these two substances are used in acidic medium? When we use, for example, potassium permanganate or potassium dichromate 6 in their neutral forms, they are not going to be oxidized fully. Okay? For example, potassium permanganate in its neutral form without the acidic medium, it forms an insoluble substance called manganese 4 oxide. This one. Okay? Manganese 4 oxide prevents further reaction. It does not provide, this one does not do it. Does not provide manganese 2 ions in solution. We need these ions, but in this case, they will not be available because this one is an insoluble substance. Okay? So we need an acidic medium to make sure that this one completely ionizes and completely reduces, is completely oxidized into, is it oxidized or reduced? Yeah, it is completely reduced from manganese 7 to manganese 2. Are we together? That's reduction. So we need an acidic medium. The most commonly used acid to acidify this substance is sulfuric acid because it is a strong acid. Okay? Yeah. So how do we acidify them? We just put them in the acid. For example, potassium permanganate in the presence of sulfuric acid, you form acidified potassium permanganate. So it contains hydrogen ions from the acid. Are we together? Yes. So this one is solid, this one is acidified. This is neutral, this is acidified. You understand? Yes. Yeah. So this one is the one that is going to provide manganese 2 ions in solution, but this one does not. You understand? Yes. Yeah. Now let me demonstrate how oxidation and reduction takes place. That's all. Yes. Yeah. Oxidation and reduction. We have said that oxidation is losing of. Are we together?
Yes.
So two ions lose electrons. So they are oxidized from ion 2 to ion 3. Okay? Each ion 2 loses 1 electron. And so is oxidized to ion 3. Is oxidized to ion 3. So you demonstrate it this way. Ion 2 loses 1 electron. So it forms ion 3. 1 electron gone. Okay? More positive means more space has been created because electrons have been lost. You know, electrons are negatively charged. Okay? So each ion 2 loses 1 electron to form ion 3. So this is oxidation. Okay? This is oxidation. Then, in the case of potassium permanganate, the manganate 7 ion. The manganate 7 ion undergoes what we call, is it oxidation or reduction? Reduction. So it's reduced to manganese 2 ion. So it requires the oxidation number of manganese. Can you note down this one? Oxidation number of manganese in potassium permanganate is positive 7. Okay? The oxidation number of manganese in manganese 2 solution is what? Positive 2. Manganese 2 solution, we talk about the acidic medium here, we are talking about sulfuric acid. So manganese 2 solution is manganese 2 sulfate. Okay? So the oxidation number of manganese here is positive 2. So whenever there is a reduction in oxidation number, this one is also called reduction. We have said reduction is gaining of electrons, but it also means decrease in oxidation number. Okay? So there are two definitions of reduction. Gaining of electrons or decrease in oxidation number. So how many electrons are needed to move from here to here? 5. Okay? So manganese, so it requires 5 electrons to be. Yes, let me just say that 5 electrons and demonstrate with an equation. So this one is acidified, so it exists as a solution. Okay? It exists as a solution like that. So inside this solution, we have potassium ions aqueous, and we have manganate 7 aqueous. Okay? So when you write a full equation, this ion is going to be repeated on the right hand side of the equation. Okay? So it cancels out. The ion that remains is this. Okay? So you omit potassium. You only write manganate 7 ion this way. The valency is 1. It is in solution. So this ion, we have said, it requires how many electrons to be reduced? 5 electrons to be reduced. Okay? But that one can only happen for you to convert this solution into aqueous. There is an acid, and an acid provides hydrogen ion. Every acid provides hydrogen ions. In the presence of 5 electrons, we have said it is reduced into manganese 2. It is written like this. Okay? Manganese 2. And then water is going to be formed because we have hydrogen ions and oxide ions. Water is also going to be formed. Now, here we have 4 oxygen atoms. We need 4 here. I think that. So this 4 times 2 gives 8. Are we together? Yes. So this is an ionic equation showing how manganese 7 ion is reduced to manganese 2. You understand? Yes. Yes. In the case of potassium dichromate 6, potassium dichromate 6 is written like this. Potassium dichromate 6 is written like this. The dichromate 6 ion, is reduced to chromium 3. Each dichromate 6 ion is reduced to chromium 3 ion.